Hi there, this is Mrs McTaggart. In this video we're going to look at changing the subject of a formula. This is the second of two videos, a bit more complicated examples here, more exam style, where we're looking at powers and roots and possibly some fractions too. And I will work through a couple of recent exam paper questions with you as well. So remember, changing the subject is trying to rearrange the formula so that it is in the form h equals. Now in an exam it will clearly say change the subject of the formula to h, but for the sake of quickness and the style that we set it out in class, we just put an h in a bracket beside it because it's less writing. So first thing I do is, I know my pupils, when they do simple equations, they always like to get the letters on the left, so the thing they're trying to isolate or find is on the left. So a good tip would be just reverse the equation first of all. Switch the good old left hand side to the right hand side, and that doesn't alter the equation at all, okay? Now we need to get h in its own, so there's a couple of things we have to look at here. We have to deal with the squared, the fraction and the -3. So I'm just going to remind you of some very basic stuff. If you had a very basic equation of 2x plus 4 equaled 10, you would deal with the plus 4 first. If you had like a fraction, if you had like x over y equals 4, well then you would deal with the y first, but I've got the stray thing, so I'm going to deal with the stray thing. And then if I take you back to Pythagoras, when you get something like h squared equals 25, that's when you do a square root to the opposite side. So you cannot square root unless you have got the letter isolated. So in this case, that's going to be our very last step. So what I just rubbed out there was basically just taking you back to very basics to try and help you distinguish what you're going to do first. And a lot of the time when I tell my class, sometimes it's the last thing you wrote which is the first thing you deal with. So when I was writing the left hand side, the last thing I wrote was the takeaway 3. So I'm going to counteract the takeaway 3 by adding 3 to each side, which gives me h squared over g equals f plus 3. Then I have h squared divided by g, so I'm going to do the opposite of dividing by g, and I'm going to times both sides by g, which leaves me with h squared equals, now there's two things to multiply by g, so I'm going to put a bracket around it. So it's going to be g bracket f plus 3. There's no need to multiply that out. And then the last thing to deal with is, like in the Pythagoras, when you've got h squared, the opposite is square rooting. So we have to square root the full right hand side, so a nice big square root that looks like it's covering absolutely everything. And that is us change the subject of our formula to h. Okay, we're going to look at this one. This looks a bit more like a kind of volume formula. It's got fractions and squareds in it. So we need to isolate v, so we're going to flip it first of all. So I'm going to write 1/4 v squared w equals t. Now all these things surrounding v are multiplying them, but a quarter, technically, remember in maths, stands for divide by 4. And the opposite of quartering is quadrupling. So I'm going to get rid of the fraction first because we don't like fractions. So we're going to times both sides by 4, which leaves me with v squared w equals 4t. So remember what I said, if you've got a fraction, sometimes it's not always written as obviously. I mean, this would be much nicer if they wrote it like that, because you're much quicker at spotting to get rid of the 4 if it's underneath everything as a denominator, rather than out the front as a multiplier of a quarter. However, we're getting rid of the fraction, we're times the opposite side by 4. Then the v squared is multiplying by w, so we're going to divide by w, which leaves us with v squared equals 4t divided by w as a fraction. And then again, same as the last one, the opposite of squaring is the square root. Now my only tip is here, make sure your square root covers the whole fraction, because there's nothing worse than us seeing someone get to the final answer, writing this, and it looks like the square root's only over the top line. So that's a big no-no. It has to go with the full fraction, okay? Here's another one with the fractions. So you've got two options here. Do we multiply out the bracket and create loads more fractions, or do we try and get rid of the fraction? Now 3/4 is just another divide by 4 one. This would be a wee bit like writing 3x plus 3 bracket x plus 2 all over 4. It's just the 3/4 in a different position. So I'm going to get rid of the denominator of dividing by 4 by timesing by 4. Now hold on, I need to flip it first of all. So I'm going to times the opposite side by 4. I'm going to times both sides by 4 technically is the method I'm using today, which leaves me with 3 bracket x plus 2 equals 4y. Remember, the number always goes before the letter. Then it's up to you. Do you want to multiply out the bracket, or do you want to divide by the 3? Either or. I'm going to do the divide by 3 one first because it's less working. So if I divide both things by 3 now, it creates a fraction on the other side, leaving me x plus 2 equals 4y over 3. And then the last thing is to deal with the plus 2, so we're going to take away 2, and I'm left with 4y all over 3, and take away 2 ends up added on at the end. Now remember, I did say there was another way. I could have gone and multiplied out the bracket and said 3x plus 6 equals 4y, and then taken over the 6 and got 4y minus 6, and then divided by 3 and be left with 4y minus 6 over 3. And they are the same answer, and just remember what I said is basically it's because that 6 over 3 would simplify to just 2, the 4y would just be left over 3. So both of them are perfectly acceptable in the exam, okay? Okay, here's one with a square root. Now this catches folk because we're really good at knowing the opposite of x squared is the square root of the other side. But quite often when I give you the square root, we forget that the opposite of that is squaring. They are the inverse of each other. So this is an example where I've got something over a fraction. The last thing I was writing down there was a divide by 2. So that's the first thing we're going to deal with, is get rid of that fraction once I flip it, of course. So I'm going to multiply each side by 2 to eliminate the fraction. So that gives us 2m. Now a wee bit like I said, when you had h squared equals, you couldn't square root the other side until it was h squared on its own. You also can't do the opposite of a square root unless it's square root of n on its own, which means we need to get rid of that number 3. So the opposite of the 3 in the front is times in the square root, so we are going to divide by 3. Which gives us a square root of n equals 2m divided by 3. Remember, the opposite of square rooting is squaring, but because we've got a fraction, we need to make sure that the squared covers everything. So we put a big old bracket around it and a squared sign, okay? Now, another possible option for this one is you could square everything and say, right, well, 2 squared is 4, m squared is m squared, and 3 squared is 9. That would be acceptable as well. What we do not want to see is this, because that looks like you've only squared the m. It's everything that's got to be squared, hence the big bracket. So that's a big no-no, okay? Okay, question 5, another one with a square root. So this time, the square root surrounds everything. So think about it being like everything is trapped in by the square root. So I can't move that 3 or the m until I've taken it out of the square root. So we know the opposite of square rooting is squaring the other side. Now I'm just going to rewrite it because I know that's what I've been doing in my other examples. So I'm going to square the other side, which leaves me L over 3m equals k squared. Now I want m on its own here. Now m is on the denominator of a fraction, which we don't like, so we need to bring that to the top. And the easiest way to do that is at the moment that's a divide by m, so we're going to times by m, and I'm going to leave the 3 where it is. So I'm going to have L over 3 equals k squared m. And then all that's in my way of m being on all its own is that k squared. So k squared is multiplying it, so we're going to divide by k squared. Now normally the k squared would go down to the bottom if we're dividing, but I cannot write, for example, I cannot write this, okay? There is already something on the bottom acting as a divide, which is a 3. So the k squared goes down and joins the 3. And we get m. So essentially, if I took you back a couple of lines, the k squared and the m are switching places. Now that's a bit of a tricky one. Okay, so that's me showing all my examples. What I'm going to do is I'm going to show you a couple of previous exam ones. So this was the one from the 2022 paper, and it caused people a lot of wee bother because we're that used to the change of subject questions being 3 marks. In this particular year, it wasn't. And also, you're used to thinking, oh, is a c squared, I have to square root somewhere. They're not asking you to change it to c. They're not asking you to touch that at all. It's the b we want. So I'm just going to reverse it first of all. So I've got c squared equals d. Now that says divide by c squared, so I'm going to times by c squared. So I'm going to have b plus 4 equals, now you've got 2 options. You can write dc squared or you can write c squared d. So remember, the other way is it could be dc squared. But I like it alphabetical, so I'm leaving it as c squared d. Okay, and then all I need to do is deal with the plus 4. So I'm going to subtract 4 from each side, which leaves me with b equals c squared d take away 4. So as I said, you didn't have to touch the squared at all. It was just an addition to the capital C. And there was people trying to square root in the exam, but it wasn't necessary. And I think that's what threw people, because there was only 2 steps to that one. Okay, so this one came from the 2021 exam paper, the one where you did the exam in school and it wasn't under the SQA, the usual SQA conditions. So this one, it was very similar to the one I did a couple of examples ago, which had the M and the K, but this time the thing we're trying to find is the H, which is on the top line, so it's actually not as difficult. So I'm just going to reverse it first of all. So 3H all over 2 equals D. Now remember what I said, if there's a square root over everything, you cannot move the 3H or the 2 until you deal with the square root. And in this question in the exam, you were actually penalised a wee bit more. If you moved the 3 or the 2, first of all, you actually couldn't then be awarded the mark 2. You could only get the final 3rd mark for maybe the last step. So just watch, massive square root over everything has to be dealt with first. So I'm going to square the D, which leaves me with 3H over 2 equals D squared, because the opposite square root is squaring. Then I'm going to undo the fractions, so I'm going to times each side by 2, which leaves me with 3H equals 2D squared. And then it should be second nature by now to divide both sides by 3, and you get H equals 2D squared all over 3. So remember what I said about the square root for this one. You could only get 1 mark if you didn't deal with the square root first, because there wasn't really any other option here. So, for example, let me show what a lot of people did in the exam. So this is completely wrong, remember. So they did, square root of 3H equals 2D. Square root of H equals 2D over 3. And then they said H was 2D all over 3 squared. So mathematically, this is nonsense, because we couldn't undo the divide by 2 yet. This was nonsense because we couldn't move the 3 yet, even though we were technically still timesing by 2 and dividing by 3, which were the correct operations. They were in completely wrong order. So all you could possibly get was the 3rd mark in that one. So please be very, very careful, okay? And then this one was the 2019 one, a wee bit different again. We've got a fraction. So this is one of the ones that had 2 different options. And we wanted to change it to x, so I'm going to rearrange it first of all. So half h bracket x plus y equals a. Now this one was joyous to March, because a lot of people tried to multiply out by a half or multiply it by a half h. But remember what I said, you don't want fractions. So remember the opposite of halving is doubling. So we're going to double each side, which leaves us with h bracket x plus y equals 2a. Then I'm not going to multiply through by h, because that would create h's everywhere. So I'm going to divide by h. But you could multiply through by h. I'm just going for the shortest answer. And that would give you 2a all over h. And then the last bit would be undo that plus y by minus and y. So you would end up with x equals 2a all over h minus y. Okay. Now, what you do not do is, you might think, oh, that h is timesing by a half. Do not ever write a divided by 1/2 like that. That's not fully simplified. And if you leave something with a fraction under a fraction, you'll get heavily marked down, because remember, dividing by 1/2 is the same as flipping it and making it a times by 2. So you need to recognise if you've got a half, that's your half, and the opposite is doubling. So just watch out for that one. Okay, so this brings us to 2018. We're nearly here. So this one was a wee bit different because the square root had something in front of it. Again, I did one earlier with a 3, I think. A lot of people got a bit muddled with this one. I want to take you back to absolute basics again and think of your equation where you've got 2x plus 3 equals 11. Deal with the stray thing, so deal with the plus 3, which in this case is a plus h. Then we'll deal with the thing multiplying the x, which in this case is the g. Then the last thing I'm going to do here is the square root, because the only thing that's under the square root is the x. And I can't undo the square root until I've got it completely on its own on that one side. So I'm going to rewrite it first of all. So g root x plus h equals y. I'm going to do the opposite of add h, and I'm going to take away. So I've got g root x equals y minus h. Oh, I nearly did a g there. And then that's, the root is being times by g, so we're going to divide by g. So we've got square root of x, y minus h divided by g. And then the last thing is to square. And remember, there's quite a few things there to square, so we're going to put a big old bracket around it and square it up there. Okay, that was a tricky one, and that's why I put that one in. Right, my last example of square is this one. We're going to change this one to A. Now, this one again caused a bit of confusion because there was a squared in it that you didn't have to touch. So people are used to seeing a squared and thinking, oh, I've got to square root somewhere. No, you don't, okay? We want A in its own. So the first thing we're going to deal with is the UT, which is my stray thing, as I call it. So we're going to take away UT, which leaves us with 1/2 AT squared equals S minus UT. Right, I don't like that half, so I'm going to double the other side. So I'm going to have AT squared equals double of S minus UT, and I'm putting a bracket around it because there's a couple of things there. The last thing I need to do to get A in its own is get rid of the T squared, so I'm going to divide by T squared. So I have 2 times my bracket all over T squared. Okay. So that's my final answer for that one. So as I said, things we saw wrong this year on this one is if I take you back to this line here, people would say, right, I'm going to do S minus UT and I'm going to divide by 1/2 T squared. Now technically the things surrounding the A were the half and the T squared, and normally I would say, oh, if there's more than one thing multiplying, yeah, take the two of them together. But this is not fully simplified. We shouldn't have the fraction over the fraction. So just be careful of that as well. Listen, I hope this has been helpful. Thank you very much for watching. Bye bye.